Okay, this is a lesson on kind of basic polynomial addition, subtraction, and multiplication. So first we'll talk about some different kind of vocab so that we all know what I'm talking about. Okay, so if we have a polynomial that is just a function with lots of different terms, something like this one. This one has 4 terms, so terms are separated by either by addition or subtraction. Multiplication is still considered one term, so that doesn't separate things. So this one has 1, 2, 3, 4 terms. Okay, so a few other different things we talk about are the coefficients of a term. So the coefficient of this term would be the 3. The coefficient here, looks like it doesn't have 1, but it's kind of an understood 1, okay? This one doesn't really technically have a coefficient because it's a constant term. It doesn't have a variable in it, so it doesn't have an x. So we would still kind of talk about it as 7, okay? But it would more be called a constant, not a coefficient. This one has a coefficient of 1/2. Another thing we can talk about is the degree of a term. So the degree is just talking about the exponent. Okay, so the degree of this term would be 5. The degree of this term would be 14. Degree here, there's no variable, so that's a 0 degree term because there are 0 variables. This degree is hidden again. It's understood to be 1. If we wanted to talk about the degree of a polynomial, you would look at the degree of each term and then pick the highest one. So the degree of this polynomial is 14 because that is the biggest exponent. Okay, so now that we have kind of some basic vocab, let's actually look at adding and subtracting polynomials. So if we have something like this, let's see, we have 3t cubed plus 2t squared minus 5t plus t cubed minus 6t. Okay, there's a few ways we can think about this. We can look at it just how it is, and then we have to find terms that are exactly alike, meaning they have the same variables and the same degree on the variable. Okay, so we would look, we don't care about the coefficient yet, we just are trying to find another t cubed term. We have 1, right? So then we look at their coefficients and we add those together. So this is 3t cubes, this is 1t cubed. So that means in total we have 4t cubed. Now something I like to do is I like to some way mark off that I've used it, I've combined them already. If underlining that is good for you or crossing them off, something, right? Okay, then we look at 2t squared. We don't have any other t squared terms, so there's nothing to combine with that one. It's just still plus 2t squared. Okay, then we have t and t. So then we look at their coefficients, minus 5 and minus 6. Well, if we combine minus 5 and minus 6, that's essentially like adding the two numbers. 5 and 6 make 11, and then you just put a negative on it. So it's just minus 11t. So that's one way we can do this problem. Another way is on how you write it out from the very beginning, okay? So from here, we would change how we write this. We would write it as 3t cubed plus 2t squared minus 5t. And then instead of writing it next to it, we would write it underneath and line up the like terms. So we would be adding, and we have a t cubed, we don't have a t squared, and we have a minus 6t. See how it already kind of gathers everything that are like together? So that can kind of help you sort things in a way. And then you just add down like a normal addition problem from like preschool practically. So 3t cubed plus 1t cubed, we already know is 4t cubed. And then there's nothing to add to this one, so it's just plus 2t squared. Combine negative 5 and negative 6, that's negative 11t. and we get the same thing. It's just two different ways of doing that same problem. So either of these methods will work. Okay, so next is subtraction. If we want to subtract two polynomials, well, we have to be careful because of that subtraction sign. So if we have something, now these parentheses are important, so don't get rid of them too soon. Okay, so if we have these two polynomials, we have to be careful about this minus. Now parentheses do not always mean multiplication. They can, but only if something is right next to each other with parentheses. This minus in between means we're taking this whole group minus this whole group, okay? So essentially what you need to do is almost distribute this negative into every term, because essentially what this really is, it's a -1 times this group of things. So we need to distribute to the first term, the second term, and the third term. So if we rewrite this, we can rewrite it exactly how it is, or we can rewrite it into that second method that we used for the addition. I personally kind of like that second method, but if you don't, then it really doesn't matter. Either way will get you to the same place. So we have 3x squared plus 2x minus 5. And then, because after we take the subtraction through, really we're adding then. We've already distributed the negative throughout, so we can add now. So we have -1 times 4x squared. That's -4x squared. So gather it with the x squared term. Then -1 times -7x. That's plus 7x. -1 times plus 2 is -2. And then just combine down. 3 minus 4 is -1. You don't have to write the 1, you can if you want to. And then 2 plus 7 is plus 9x. -5 minus 2, or -5 plus -2, is -7. This would be our answer, okay? So you can kind of check that by looking and saying, okay, well, I'm taking this away from this. Okay, that's the thought process on these. Okay, so that's subtraction of polynomials. Next, we'll do a multiplication. So with multiplication, you have to keep your exponent rules in mind. Okay, so otherwise, the multiplication can kind of go a little wacky. So the first thing that we should talk about is that if we multiply two monomials together, meaning just a function with one term. Excuse me. Okay, so if we have these two monomials, the easiest way of doing it is always look at the numbers, then look at the next variable, then look at the next variable, okay? Take it one piece, one step at a time. Don't try to do everything all at once. You'll get overwhelmed if you do. So 3 and times 5, well, that makes 15. X squared times x cubed, well, we have same base being multiplied. That means, what exponent do we use? Well, we end up adding the exponents, because essentially we're saying we have 2x is being multiplied times 3x is being multiplied. That's overall 5x is being multiplied, right? Well, we added the 2 and the 3 together. So that's x to the 5th. Then we have y to the 7th times y. Remember, that's a y to the 1st. So that means when we multiply them, we add, so it's y to the 8th. And that's it. That's the answer. We did everything that we could. We multiplied the two polynomials together to end up with our answer. Okay, so that's two monomials. Let's talk about if one of them was not a monomial. If we have 5y cubed times 2y squared minus 7y plus 6. Okay, This one is exactly like on the subtraction where we took the negative through everything. We're going to distribute this whole front piece to every term within the second part. So 5y cubed times 2y squared. So again, take the numbers times each other, then combine the variables. So 5 times 2 makes 10. Y cubed times y squared, remember to add, so that's y to the 5th. So that's that term. Then we have 5 times negative 7. That's negative 35. And then y cubed times y is y to the 4th, again add, and remember that's a hidden 1. Then we have 5 times positive 6, that's plus 30. There's no y's here, so it's just y cubed. Okay, we should notice all of these have 5 in common because we multiplied a 5 through, and all of them have at least 3 y's because we multiplied y cubed through. So that's multiplying a monomial times a more than a monomial, okay? You just distribute. Okay, next is if we take two not monomials times each other. So we will have 2x squared plus 4 times 3x squared minus x plus 5. Okay, now again there's technically multiple ways we can do this. We could take the first term and distribute it to all 3 pieces, and then the second term and distribute it to all 3 pieces. That is perfectly valid, okay? Just like the first one we did, the addition, there's multiple ways of doing it. Almost any math problem, there's multiple ways. It's just the one that you are most comfortable with. I'll do that version first, then I'm gonna write it out kind of like we did the addition and subtraction, how you write it out and then do the multiplication that way, kind of like how you multiply big numbers. So first we take this to here, here, and here. So 2x squared times 3x squared, that's 6x to the 4th. 2x squared times negative x, that's negative 2x cubed. 2x squared times 5 is plus 10x squared. 4 times 3x squared, then we take this one times each of these. Again, see how we're just taking both of these terms and distributing it throughout. Now, if there were more than 2 terms, this would get a little hairy looking, right? There'd be a lot of terms. So 4 times 3x squared is plus 12x squared. 4 times negative x is negative 4x. And 4 times 5 is plus 20. Now, we still have to combine like terms if we have any. We're not always going to have like terms, but generally there's a couple at least. So we only have one x to the 4th term, right? So that's just 6x to the 4th. We only have one x cubed term, so that's just minus 2x cubed. We have 2 x squared terms, however. So 10 and 12 make 22x squared, and then just minus 4x and plus 20. Nothing can be combined from this point, and that's our answer. Okay, let's do this one other method. Okay, now we're going to write this out in, like I said, in the kind of long multiplication method, like we do when we have big numbers. So what we want to do is write out the bigger one first. See how this has 3 terms? So we want 3x squared minus x plus 5. Then write 2x squared plus 4. Line up the like terms just like we did with the addition. Now, you take the 4 times everything, just like normal multiplication, right? You start with the first unit, and then multiply everything. So 4 times 5 is 20, positive 20. 4 times negative x is negative 4x. 4 times 3x squared is 12x squared. Then we did this one, right? So you write a 0. There's nothing here. So you write another 0. 2x squared times 5 is 10x squared. See how they're lining up? Because we put those zeros. And then 2x squared times negative x is negative x cubed, 2x cubed, sorry. There's a plus there. And 2x squared times 3x squared is 6x to the 4th. I didn't leave myself enough room. And then we add down because everything's lined up correctly. So 20, negative 4x, 12x squared and 10x squared is 22x squared minus 2x cubed and 6x to the 4th. That's exactly what we got the other way as well. So you can pick one of the ways and do it that way. I would be consistent, pick one that you like, right? And do it always that way. Now, I will, however, mention that if one of them is a monomial, just distribute the first way we did it. That's always going to be the easier method if it's just one of them is one term. If you have them like this, so this is like the first one that I would definitely for sure do this way, okay? If they were both just binomials, 2 terms, then I would distribute or use what we call the FOIL method, right? So FOIL is first, outer, inner, and last. Okay, so if we have 2 terms like this, let's just say a plus b and a minus b, sorry. First would be the a's times a's. Outer would be a times b. Inner would be b times a. And last would be b times b. Okay, so you get all of the full distribution like we did the first way on this one. But that only works on 2 binomial terms, okay? This way works a little bit better when you have more terms, okay? When one of them is a 3, or when both of them are 3 terms, or more, okay? We don't get too many of those, but it is a possibility. Okay, so that is polynomial kind of math.